Before we get to the next stages, we need to make sure that you can talk about solids, liquids and gases with precision. So we're going to review those terms in this lesson video, and then we're going to look at Brownian motion, an often misunderstood phenomenon. Let's start by sketching models for solids, liquids and gases. So go and get yourself a piece of paper or something. Pause while you're grabbing yourself something to write with. Now I'll do the first one, the solid, with you to make sure you know the kind of style I'm looking for. After that, I want you to have a go solo. Right, so if you've got something to draw with, a typical solid is drawn like this. In fact, solids don't always look like this, but it is an excellent way to represent the special features of solids so we can easily determine the properties from the drawing. Now I'm not drawing them too small because it would take forever to fill the box. As you probably know, the particles don't just sit still, they vibrate in place, so I'll draw some marks to indicate vibration. From this, we can see the ordered structure with directional bonds, forces between the particles. This means that solids retain their shape and do not flow. It also means they cannot be compressed, since there are no gaps between the particles. So now you really should pause the video and have a go at the other two. Carrying on, here's my liquid. It can be tough to draw because I don't want everything lined up perfectly, but I also wanted to keep the particles in contact. That shows that the liquid cannot be compressed, but that the liquid does not retain its shape. It fills the shape of the container. As the particles can move, we should draw some arrows to show this in a few random directions. But there are forces between the particles keeping them together. They're just not as strong like the ones before. Alright, so now pause and update your gas if you think you're going to need to. Mine is going to look like this. I've got a few particles scattered around, each with a longer arrow. This shows how the particles are spread out with no forces between them. The gas particles will spread out, filling the container. And with all that space between the particles, that means that a gas can be compressed. Changing between the three states is typically just a case of moving thermal energy in or out. Going from a solid to a liquid is melting, and a liquid to solid is freezing. There are longer words such as solidification and liquefaction, but freezing and melting are just fine. From liquid to gas is evaporation, with condensation in reverse. Or go with vaporization or gasification on liquefaction if you really must. And lastly, gas to solid is freezing or solidification, with the less common reverse being sublimation. The last bit to cover is Brownian motion, named after botanist Robert Brown, who pioneered use of a microscope. Now, Brownian motion is often misunderstood, so let's clear things up. Firstly, Brownian motion is the random movement of large particles such as smoke or pollen, or the little particles that might be given out from pollen. It's caused by the random movement of tiny invisible particles such as air or water. But the Brownian motion itself is the bigger visible particles. What happened was that Brown saw the movement of tiny particles in water and he knew it wasn't alive, but it was 80 years until the results were used in full, with Einstein bringing greater attention to it. The theory goes that the observed movement is caused by invisible particles in the water. These must be travelling in random directions because when they collide with the larger particles, they cause the large particles to move in random directions. The small particles really are very small, so in order for them to make such a big particle move, the small ones must be travelling very fast. By the way, not just fast, very fast. So, Brownian motion is the random, zigzag movement of large particles suspended in a fluid, caused by collisions with very fast, very small particles from random directions. It can be observed under a microscope, with one common method being the smoke cell shown here. Some smoke is placed in the cell and a microscope is used to view the cell. With careful observation, it's possible to see small specks of light moving with Brownian motion. This is the light reflecting off the smoke particles. It's well worth your time trying to observe this yourself, so if you can't see it in a lab, then there are plenty of example videos online you can take a look at instead. So in this lesson video, we've looked at the distinguishing properties of solids, liquids and gases, we've looked at the molecular forces, and we've also looked at Brownian motion. In the next few videos, we're going to look in more detail at gases and how the pressure relates to other properties such as temperature and volume.